They looked as if they were drawn not by engineers, but by mad dreamers, as if someone had decided to embody the drawings of a schoolboy in the margins of a notebook in metal. Airplanes with propellers in the middle of the fuselage, with wings, bridges, and cockpits where the pilot seemed to sit in an aquarium, ready to crash down with tons of bombs. These machines were supposed to replace a legendary piece of equipment, but they turned into symbols of insane despair as Germany lost the skies and grasped at the most incredible ideas. These projects had it all, an audacity that chills the blood even today, courage bordering on madness, and solutions that the military rejected as too dangerous. But therein lies the intrigue. What did the mad blueprints of Blohm and Voss hide? Why did they frighten even their own allies? And what could the future of warfare have been if at least one of these monsters had taken to the sky? You'll find out at the end of the video. In the midst of World War II, Germany found itself in a situation where every new technical solution could be decisive. It was here, amidst the workshops, laboratories, and design bureaus, that projects were born which today seem more like fantasy than engineering practice. Some aircraft had asymmetrical fuselages, as if nature itself had intervened in the design process. Others were equipped with cockpits in the most unexpected places, for example, extending to the edge of the wing, as if the pilot were to observe the battle from the side turret of a ship. There were also those that looked like sketches from a school notebook. Bold, absurd, yet captivating. The reasons for such bold ideas lay not only in desperation and mounting military pressure, but also in the peculiarities of the German engineering school. There was a tradition of seeking unconventional solutions, even if they appeared too daring or incongruous. In conditions where resources were dwindling and adversaries were strengthening, taking a step away from the familiar became not madness, but an attempt to outrun time. And the Air Ministry, fully understanding that any new weapon could be decisive, gave engineers relative freedom. This created space for ideas that, in other circumstances, would have remained mere notes in the margins. Among the companies that dared to experiment, Blohm and Voss stood out. Not long ago, it was known as a shipbuilding giant, but the war rapidly transformed it into an arena for aviation daring. The main inspiration here was Richard Vogt, an engineer capable of drawing designs that simultaneously evoked laughter, bewilderment, and sincere admiration. The blueprints of this firm featured machines resembling characters from future science fiction films, or even abstract art objects. But each of them had a practical goal: to find a way to strike the enemy from an unexpected direction. It was this blend of desperate search and engineering creativity that forged the company's reputation as the mad genius of German aviation. And at the moment when the threat of defeat in the air loomed over Germany, it was Blohm and Voss that undertook the creation of a project destined to become one of the strangest aircraft in history, the P.192. When the war first began, the Ju-87 became the symbol of the Blitzkrieg. Its characteristic howl during a dive was not just an auditory accompaniment to the attack. It was part of a psychological weapon that paralyzed the enemy even before the bombs hit the ground. This aircraft could descend almost vertically, and its automatic dive recovery system saved pilots from the G-forces that could otherwise render them unconscious. For the German army, the Stuka proved to be an ideal instrument: cheap, reliable, easy to handle, and incredibly accurate in bombing. It was with this aircraft that the first resounding victories were associated, as enemy armies retreated, unable to even organize a defense. However, as the war dragged on and the world changed, the Ju-87 ceased to be the terror of the skies. Its low speed became fatal. In the early stages, this problem was offset by the Luftwaffe's air superiority, but as soon as the Allies established mass production of faster fighters, the Stuka became an easy target. Even updated versions, equipped with cannons for fighting armored vehicles, could not change the situation. The heavy aircraft was slow to recover from a dive, and became prey for opponents who gained speed faster and attacked from advantageous positions. On the Eastern Front, the Ju-87 held on longer. It was there, in the vast expanses, that it remained useful as a means of army support. But with the growth of Soviet aviation numbers, its effectiveness gradually declined there too. In the West, where the Anglo-American air forces strengthened with each passing month, the situation was even worse. Germany found itself in a position where the symbol of its air superiority had become vulnerable and no longer met the demands of the time. The command understood that a replacement was urgently needed. An aircraft was required that could combine the precision of the Ju-87's attacks with the protection and speed of a modern fighter. For a time, Focke-Wulf's FW-190 filled this role. This versatile fighter, possessing powerful armament and superior speed characteristics, indeed became a temporary salvation. It was used as an attack aircraft, striking ground targets and providing support to troops. But it was not designed as a dive bomber, so its use in that role was a forced measure, not a complete solution. Thus, the question hung in the air: which aircraft would succeed the legendary but outdated Stuka? It was in the search for an answer to this question that a series of the strangest experiments began, among which the project by Blohm and Voss occupied a special place. Spring 1944 became a time when the front began to crumble rapidly for Germany. Soviet armies advanced in the east, grinding down the Wehrmacht in endless battles. In the west, Anglo-American troops were already preparing for the invasion of France. From the south, pressure intensified after the Allied landings in Italy. It seemed that with each passing week, the ring around the Third Reich tightened. And in this atmosphere of despair, the German command demanded the impossible from engineers. The Luftwaffe, having lost the initiative in the air, desperately needed new technology capable of turning the tide, at least locally. Special responsibility fell on the design bureau of Blohm and Voss. The head of the group, Richard Vogt, understood that standard approaches no longer worked. Not just an improvement of old models was needed, but a fundamentally new solution that would allow them to overcome limitations and snatch at least a modicum of advantage from a hopeless situation. It was then that the search for a miracle aircraft began, a machine that could replace the obsolete Ju-87 and simultaneously take on the role of a multi-purpose attack aircraft. The design halls were filled with an atmosphere of both inspiration and hopelessness. Engineers worked under conditions of limited time, resources, and clear prospects. But it was precisely this that pushed them to the boldest decisions. Projects with indices from P.192 to P.196 emerged on the tables. Each new blueprint was an attempt to create a machine capable of simultaneously surviving in the sky, saturated with enemy fighters, and remaining an effective tool for attacking ground targets. Vogt allowed himself what other designers avoided. His approach was almost avant-garde. If standard forms no longer worked, then one had to seek those that had never been tried before. It was this sentiment that gave rise to an entire line of projects, among which the P.192 became the boldest and, perhaps, the strangest embodiment of Blohm and Voss's ideas. When one first looks at the blueprint of the P.192, one gets the feeling that before one's eyes is not a military aircraft project, but a teenager's fantasy drawn in the margins of a notebook. Its silhouette was so unusual that even experienced engineers could hardly believe such a machine could fly. The main feature was immediately striking: a huge propeller installed not at the nose or tail, but right in the middle of the fuselage. It seemed to cut the aircraft in half, like a rotating mill cutting through a body. This strangeness gave the machine the appearance of an adornment, as if the aircraft were wearing a necklace of metal and rotating blades. The designers explained such a decision by the desire to give the pilot an absolutely clear forward view. In the conditions of a dive bomber, this was crucial. The success of the attack depended on how accurately the pilot saw the target. Moving the propeller out of the field of vision meant that nothing would obstruct the view of the ground during a dive. But the unusual appearance of the P.192 was not only a result of calculations, but also a symbol of the audacity of its creators. Blohm and Voss were known for their ability to ignore tradition for the sake of experimentation. And here they went even further. The aircraft looked as if it had been designed on the principle: first, we'll do the impossible, and then we'll figure out how to make it fly. For the military, accustomed to the classic outlines of the Ju-87 or FW-190, the P.192 was a real shock. Some saw it as a bold step forward, others as a threat of failure. After all, such a design carried too many unknowns. But the fact remained: In conditions where every new idea could offer a chance of survival, even such a monster received the right to exist, at least in blueprint form. To understand how unusual the P.192 was, it is enough to examine its structure in detail. The boldest element was the installation of the propeller directly in the middle of the fuselage. The blades emerged from a narrow slot behind the cockpit, rotating like a metal knife, cutting the fuselage in half. Immediately behind this mechanism was the engine, a powerful V-shaped liquid-cooled unit hidden deep within the fuselage. This solution freed up the nose for the pilot and armament while maintaining a compact design. To compensate for the loads and maintain fuselage rigidity, a small wing was added to the front section, connected to the main wing via short side inserts. These elements looked like bridges stretching from the nose to the center of the fuselage, and, along with the main wing, formed a peculiar three-layer scheme. The main wing itself was straight with a sharply tapering trailing edge, giving it an almost futuristic look. Vogt saw several advantages in this architecture. First, the propeller, moved from the nose, provided the pilot with panoramic visibility, which was rare for aircraft of that time. Second, the load distribution between the front and main wings was supposed to increase stability during dives, as this was precisely where the Ju-87 often encountered G-forces and loss of control. Third, the unusual scheme allowed for armament to be placed in more convenient locations. The nose section was now completely free for cannons and sighting equipment. Even the tail empennage remained classic, but against the backdrop of the other elements, it looked almost anachronistic. Overall, the impression was created that one was looking not just at an aircraft, but at an engineering experiment assembled from three different concepts. Vogt calculated that such a hybrid would combine the strengths of each idea and give the Luftwaffe a tool capable of surprising the enemy, as much as it surprised its own colleagues during development. The cockpit of the P.192 was located at the very nose, turning it into a true observation post. The pilot received a panoramic view forward and downward, a luxury that Ju-87 pilots could only dream of. In a dive bomber, such visibility was invaluable. The target was directly in front of the eyes, without distortion or interference from the rotating propeller. It seemed that the engineering concept would give the pilot not just a machine, but a magnifying glass for war, where every movement could be controlled with meter-level precision. Equally impressive was the intended arsenal. Two 20mm MG-151 cannons were to be mounted in the nose, and two 30mm Mk-108 cannons in the wingtip sections. Such a combination would allow for attacks on both air targets and armored vehicles on the ground. Additionally, the project provided for the suspension of a large 500 kg bomb under the fuselage, and if necessary, additional charges under the wings. On paper, this turned the P.192 into a formidable multi-purpose tool. It could descend upon tank columns, breach fortifications, and still remain a dangerous opponent in the air. But all this power remained on paper. The reality of war was harsher. Even the most beautiful designs required resources, time, and production capacity that Germany no longer had by mid-1944. An arsenal that seemed fearsome on paper never roared in the real sky. The perfect view from the cockpit never helped any pilot to accurately drop a 500 kg bomb on a target. The P.192 remained forever a weapon that existed only in the imagination of engineers. The P.192 project was based not only on its bold form, but also on the choice of its power plant. The designers considered two engine options, either of which could have turned the unusual aircraft into a combat machine with its own character. The first option envisioned the installation of a Daimler-Benz DB 603 Series G, a powerful inverted 12-cylinder liquid-cooled engine. The second was a Junkers UMO 213 Series A, also a V-type engine with comparable power. Both units produced approximately 2,000 horsepower, making them among the most powerful piston engines available to Germany at that time. The combination of these engines with the radical layout of the P.192 was supposed to give the machine impressive dynamics. The DB603 provided greater thrust and was considered more reliable, but was larger and heavier, making the P.192.01 version look slightly bulky. The Jumo 213 was lighter and more compact, resulting in a slightly sleeker P.192.02 variant. In this configuration, the tail empennage also changed. Instead of a constant width stabilizer, a tapering form was used, which improved aerodynamics. Engineers placed great hopes on these engines. They calculated that with an output of 2,000 horsepower, the aircraft could develop enough speed to recover from a dive and evade pursuit. In a situation where the Ju-87 was becoming easy prey, the new project was supposed to exhibit entirely different behavior in the air. Vogt believed that the combination of a bold design with proven German engines would allow for the creation of a machine capable not only of delivering strikes, but also of surviving where its predecessor would inevitably perish. However, the calculations remained on paper. The two hearts of this machine never beat in unison in actual flight. One of the most mysterious elements of the P.192 were the small wings extended forward from the main plane. They looked as if they connected the nose section to the main wing via short side inserts, forming a strange bridge. At first glance, this could be mistaken for a simple structural solution to strengthen the fuselage and distribute the load between sections. But the more closely specialists studied the schematic, the more questions arose. Some considered these surfaces purely supporting, as the unusual placement of the propeller in the middle of the fuselage weakened the overall structural rigidity. Such side elements could have served as connecting beams to prevent the fuselage from breaking at the point of separation. However, a tempting option remained. What if they were conceived as full aerodynamic surfaces performing hidden functions? There is a version that these small wings could have been a kind of dive brakes. After all, it was in this mode that the Ju-87 showed its best results. But the G-forces and the risk of losing control remained a huge problem. If the additional planes could have functioned as air brakes or even auxiliary flaps, the pilot would have had more control over the machine at large angles of attack and a safer exit from a dive. And although no confirmed documents on this have survived, the very audacity of such a suggestion perfectly matched the spirit of Blohm and Voss. Their designers often proposed solutions that went beyond the conventional and balanced between genius and absurdity. Therefore, the mysterious small wings remained a source of speculation. Were they merely strength bridges, or did they hide a secret function that could have changed the character of the entire machine? Despite all the boldness and even beauty of the engineering concept, the fate of the P.192 was decided rapidly. Military specialists, accustomed to traditional designs, viewed the blueprints with distrust. The main objection concerned the very heart of the construction, the propeller placed in the middle of the fuselage. This solution looked too risky. If the unit located directly behind the cockpit failed or was damaged, the aircraft could instantly lose controllability. Furthermore, engineers could not guarantee that the complex system with the engine, hidden deep within the fuselage, would be sufficiently reliable under combat loads and field maintenance conditions. The fact that many elements remained purely experimental also added to the problems. The small wings, the unusual layout, the weight distribution. All of this required lengthy testing, which Germany no longer had time for. The front was collapsing, and the military needed not bold experiments but quick, proven solutions that could be put into series production. Moreover, compared to existing machines, the P.192 did not offer a significant breakthrough. Its calculated characteristics looked attractive on paper, but upon closer inspection, it was clear. The risks outweighed the potential benefits. The Luftwaffe command considered that such a project would distract forces and resources rather than yield real results. Thus, the unusual aircraft, which promised to be a jewel among classic aviation forms, ended its existence at the blueprint stage. Its story was short, from bold inspiration to a silent refusal. The P.192 received neither a prototype nor trials, remaining only in memory as a symbol of how desperately Germany sought a wonder weapon, but did not dare to take the step into the ultimate unknown. After the P.192 was deemed too risky, the engineers at Blohm Voss did not stop. Realizing that their daring idea was unlikely to ever go beyond blueprints, they decided to soften the most provocative elements of the design. Thus, a new project, the P.193, emerged, which can be called the successor to the monster, but in a more refined and viable form. The main change was the location of the propeller. It was now moved to the tail, making the aircraft a classic pusher configuration. This solution looked much more familiar and alleviated some of the military's concerns. A long shaft was to transmit torque from the engine, located in the middle of the fuselage, to the propeller at the tail. This arrangement left the cockpit and nose section completely free, providing excellent visibility for the pilot and sufficient space for armament. However, moving the propeller required a redesign of the tail empennage. To protect it during landing, the engineers inverted the scheme. The vertical fin pointed downwards, and the horizontal stabilizers were located slightly higher. This allowed the tail to touch the ground in case of a hard landing, while keeping the propeller undamaged. The solution looked unconventional, but no longer seemed absurd, rather inventive and rational. According to calculations, the new machine was supposed to demonstrate impressive speed, around 300 mph near the ground and over 350 mph at altitude. The bomb load was also increased to 1 ton, making the P.193 a more serious candidate for replacing the aging Stuka. The armament was envisioned to be similar to its predecessor, cannons and machine guns in the nose and wings, as well as the possibility of suspending a large bomb under the fuselage. Unlike the fantastical P.192, this project looked like a step towards reality. It retained the daring of Blohm and Voss, but in a more restrained military manner. This was the path the designers hoped would prove that their ideas could be realized not only on paper, but also in metal. Despite the P.193 looking much more convincing than its predecessor, its fate turned out to be just as short. Paper calculations promised higher speeds than the Ju-87, an impressive bomb load, and significantly better survivability. It seemed that this particular aircraft could have become the very replacement for the legendary Stuka, but the military viewed the project differently. By mid-1944, the Luftwaffe's priorities had changed. The German command needed not new attack or dive bombers, but modern fighters capable of regaining air superiority. Without control of the skies, even the most perfect bomber became easy prey. The logic was simple. If air cover could be provided by jet aircraft like the Me-262, then the old Ju-87 could still perform its tasks. But if air control was lost, no new attack aircraft could save the situation. Furthermore, Germany's resources were rapidly dwindling. Factories were bombed by the Allies, fuel and metals were scarce, and skilled workers were in short supply. Under these conditions, putting another experimental aircraft into mass production seemed an unaffordable luxury. The military decided to focus on jet technology, seeing in it the only chance to turn the tide of the war. Thus, the P.193 shared the fate of its elder sibling. Its blueprints and calculations were added to the archives, but it never took to the sky. And if the P.192 amazed with its fantastical nature, the P.193 left a feeling of incompleteness. A project that could well have become a reality, but was denied life simply because time was already working against it. The stories of the P.192 and P.193 ended before a single prototype was built, but the projects themselves did not disappear without a trace. They remained in memory as symbols of that desperate time when German engineers, cornered by war, tried to find a way beyond the familiar. These aircraft did not become weapons, but they transformed into peculiar monuments of engineering bravery, where the line between genius and madness was almost completely blurred. Blohm and Voss cemented their reputation as a company capable of offering solutions that others dared not implement. Their blueprints resembled not strict military schemes, but drawings on the verge of fantasy and art. And yet, in every line of these projects, a logic was felt. The desire to provide the pilot with better visibility, increase stability during dives, and give the machine more firepower. Even if the solutions seemed absurd, they were backed by an honest attempt to change the course of the war through engineering breakthroughs. In aviation history, Blohm and Voss are remembered as the creators of the most unusual machines of their time, from asymmetrical seaplanes to projects with cockpits on wingtips. The P.192 and its successor became the culmination of this line, aircraft that never took to the sky but forever retained an aura of myth. Today, these blueprints evoke a slight regret. The world never saw how the rotating, jeweled propeller would cleave the air. how the unusual wings would hold the machine in a dive, and how the pilot would utilize the panoramic cockpit view. All of this remained only in the imagination of the engineers and those who, decades later, examined the preserved schematics. But perhaps therein lies their legacy, a reminder that even in the darkest times, people continue to seek new forms, sometimes too daring for their time, but always captivating to the eye and sparking the imagination.